So section 6.5, our last section, we've been talking about rational expressions. Today we're going to talk about how to solve rational equations. And just from the name, you should know what it is. It's an equation that contains a rational expression. So basically an equation with fractions. If you recalled how you solved equations with fractions in previous classes, solving these equations with rational expressions will work out similarly. So we'll start off by looking at solving graphically, numerically, and then talk about how to solve algebraically using the LCD or other techniques. All right. So definition, a rational equation is an equation that contains rational expressions, just as the name suggests. So we're going to be trying to find an x value or a value for whatever variable we're using that makes both sides of our equation true. We can use all of the previous techniques that we've learned for solving equations. So adding, subtracting, multiplying, and dividing expressions on both sides. We can do that. Yeah. And then, like I said, the one big difference between how we solved these types of equations and how we solved linear equations in the previous chapter is, well, now we have denominators, and one technique we're going to use is to clear fractions or get rid of the denominators by multiplying by the LCD. All right. Before we get into that, let's talk about how we can solve these types of expressions graphically or numerically, or equations graphically or numerically. Anytime you have an equation, you can solve it graphically by letting one side of your equation be y1, the other side of the equation be y2, and then you are going to be looking for when they're equal. So that would be the intersection point. Okay, so here in our first example that's shown in the book, we have a very simple equation. Which could be solved with cross multiply, but that's later. 1 over x equals 1 over 4. Obviously, these are equivalent when x is equal to 4, but this is an easy one that you can solve probably without graphing. But how will we solve this by graphing it? We let the left-hand side of the equation be y1, let the right-hand side of the equation be y2, and then graph them and find the intersection point. Any equation that we have can be solved graphically this way. It doesn't matter how easy or how complicated the equation is. This is always how you solve graphically. And we can see here that the intersection point occurs when, at 0.25 comma 4. The idea is if you set one side of the equation for y1 and y2 and find the intersection, boom, that easily gives you your solution. So we're going to practice solving a couple of problems graphically, and we can also solve numerically by looking at the table. So when you're looking at your table to solve numerically, you want to put your equations in for y1 and y2. You're going to go to the table feature and make sure it's on, remember, we play around with how our inputs should be, whether it's going to be auto or manually input. You want them to be on auto. So you want your independent variable to be on auto. And it'll put in numbers, -1, 1, 2, 3. Notice here a couple of small differences though. Normally, your calculator is going to be set up to where it's starting at 0, and that delta table is usually 1. That means that the calculator is going to choose x values that go up by 1, 0, 1, 2, 3, 4, 5, 6. But sometimes our answers are going to be decimals. So we might want the calculator to also show us some numbers in between the integers. To change that, you can change your delta table. So here, delta is going up by 0.25. That means that your inputs are going to be 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5. So it makes the scale a little bit smaller. You can always play around with that. And then what are we looking for when we solve something numerically? We're looking down our table and we want to know what x value has y being equal for both equations that we put in. And we can see that that's happening on this table at 0.25, 4. So quick example. We're going to solve this problem graphically, numerically. I'm going to project the TI 84 calculator. So let's go. X plus 1 over 2 equals 1 over 8. In order to do this, we're going to let y1 equal x plus 1 over 2, and let y2 in our calculators equal 1/8, and then we're going to find the intersection. All right, so in our graphing calculators, let's clear out what we previously had. One quick thing to remember when you're typing in rational expressions in your graphing calculator, you want to put your numerator in parentheses and in denominator in parentheses. So I'm going to do open parentheses, x plus 1. Where's the x? X plus 1. Then close my parentheses, divided by 2. And that equals 1 divided by 8. All right. When we graph these, I'm just going to go to Zoom Standard to see what they look like. So Zoom 6. Yeah, I guess that's right. All right, go back to my graph. We can see that there's an intersection point happening here. If you want to zoom in more on it, you can zoom in. Let's see, zoom 2. I'm going to use my arrow to move over and then hit enter. We can see that's going to be a negative decimal. All right, to find the intersection point, second, calculate, go down to intersect. We've done problems like this before. It doesn't change now that we have rational equations. This technique works for any equation. All right, we're going to press enter on each line, and then press enter one more time to find the intersection point. All right, and here we're told that the intersection point occurs at negative 0.75, 0.125. And that's our solution, yay! When x is equal to negative 0.75, both y1 and y2 equal 1/8, which is 0.125. All right, so we have negative 0.75, 0.125 as our solution. So x would be equal to negative 0.75. That's solving graphically. If we wanted to solve this numerically, well, because our answer is a decimal, we'd have a little bit of extra work to do. We can't just go and look at the table. Actually, let's just go to table now. I don't know what my table's set up as. So right now, if we look, our x values are just going up by 1. And you see what we have: 0, 0.5, 1, 1.5, 2, 2.5. Nowhere over there are these equal to 1.25. If we go the other way, we still don't get anything that's equal. But we see that between a few of these, so we go from x equals 0 to x equals negative 1. We go from 0.5 to 0 for our outputs. So somewhere in between there, or between negative 0.5 and or negative 1 and 2, somewhere in here, in between these numbers that we're seeing, these x values that we're seeing, our answer is in there. If you don't see a solution automatically in your table, that tells you that you might need to change your delta table so that you're looking at some decimals instead of just integers. How do we do that? Go to window, second window, and go to table set. And where it says delta table, that's where you can change things to change your scale, basically. I'm going to change it to 0.25. So it's going up by quarters, up and down by quarters, I should say. And our independent variable is on auto. Then when we go, let's also start, we can start at -5, that's fine. We go to the table and we scroll down. You see here that we have more numbers. Instead of just the integers, we have the decimals in between as well. And if we scroll enough, we'll get to our answer. Oh, I passed it. There it is. And negative 0.75, both outputs are equal to 0.125. So that's our solution, and that's how we solve graphically and numerically. Same ideas as before when we solve graphically and numerically. All right, so let's get back into our workbook. Solving rational equations algebraically. One technique that you can use is to multiply everything by the LCD. This is called sometimes the method of clearing fractions, because the idea is you have these rational expressions, which are algebraic fractions. Solving equations with fractions can be a little bit messy with the denominators, especially if there are different denominators. What's a nice way that we can solve this without having to deal with all the fractions? Get rid of them. How can we get rid of the fractions? Multiply everything by the LCD. So the LCD technique is nice because once you find your least common denominator and multiply everything by the least common denominator, all of your denominators will cancel out. You'll have a nicer equation to work with, something that's either linear or sometimes quadratic, something that we know how to solve. All right, I'm just going to skip through this example that is shown here and go straight to our steps. These are on page 4 in the book. Solving rational equations using the LCD method. Step 1, find the LCD. So look at all of your denominators, and remember every factor that appears in a denominator has to appear in the LCD. Okay, then you're going to multiply both sides of the equation. And that's every single term in the equation. You're going to multiply by the LCD. When you simplify, all of the denominators should cancel out. And then from there, you'll be left with an equation that's either linear or quadratic or something you can solve by factoring. It'll be an equation that's solvable for us, okay? And then this is very important. When we solve, we're going to get answers. Sometimes we get solutions that are not actually solutions to our rational equation. Those are called extraneous solutions. So once we find like x equals 5, x equals -2, we actually have to go back in and check to make sure those answers actually work, because they don't always work. All right, let's jump into some problems where we do this. Problem 1, solving 1 over x equals 4 over 25 using the LCD. I feel like we should also talk about how we can solve problems like this using cross multiplying, but that'll come up a little bit later. So let's just use a method that we're asked to use. If we look at our two denominators here, x and 25, the LCD would be 25x. So if we multiply both sides of the equation by 25x, what happens? On the left-hand side, sorry, that does not look very good. Let me fix that. Is that better? All right, on the left-hand side, the x's cancel. On the right-hand side, the 25's cancel. So we end up getting 25 is equal to 4 times x. And then from here, this is a one-step linear equation that we can solve by dividing both sides by 4. We divide both sides by 4, we get 25 over 4 is equal to x. And that would be our answer. As with all equations, you can check your answer by plugging it into the original equation to see if it actually works. Is 1 over 25 over 4 equal to 4 over 25? The answer is yes. 1 over 25 over 4 is just 1 divided by 25 over 4, which is 1 times 4 over 25. So when we simplify this, both sides of the equation equal 4 over 25. So that checks out. All right, on to part B. We have 1 over x minus 1 equals 2 over 3x. Our LCD in this case would be x minus 1 times 3x. Okay, so if we multiply everything by these two, or I'm sorry, by the LCD, on the right-hand side here, we have x minus 1 times 3x. On the left-hand side, we have x minus 1 times 3x. Stuff cancels. On the left-hand side, the x minus 1s cancel out, and on the right-hand side, the 3x's cancel. So we'll be left with 3x is equal to 2 times x minus 1. All right, once we multiply by that LCD, all of the denominators disappear, so now we have a linear equation that we can solve. Let's solve it. That's 3x equals 2x minus 2. And then if we subtract 2x from both sides, that leaves us with our final answer, x is equal to -2. All right, let's check our answer here. If we plug in -2 for x in that original equation, we have 1 over -2 minus 1 equals 2 over 3 times -2. Is this true? That's 1 over -3 equals 2 over -6. And yes, 2 over -6 does simplify to -1/3. So both of these are -1/3. It checks out. All right, so both of those equations were easily solvable by multiplying by the LCD. When we multiplied each side by the LCD, the denominators canceled completely, and we got linear equations that were pretty easy to solve, okay? Both of those also had only one expression on each side of the equation. So essentially, you could have just solved those with cross multiplying. But for the next ones, C and D, we actually can't solve with cross multiplying. I know I'm not gonna have enough room to do both of these here under the thing, so I'll do C on top and then D on the bottom. For C, actually, we might have space. C isn't too bad. We have 1 over x plus 1 over 5 equals 7 over 10. So what is the LCD in this case? Our denominators are x, 5, and 10. We know we're going to need to have an x. And then 5 and 10 both share a factor of 5, so we need a 5. And then 10 also has a factor of 2. So if it helps, we can write this as 2 times 5. So we need a 2, a 5, and an x. Our LCD is 10x here. We multiply each of these terms. Remember, both sides of the equation, every single term, we're going to multiply by 10x. And then if you simplify properly, all of the denominators should cancel out. So 1 over x times 10x, the x's cancel, and we're left with 10, plus 1 over 5 times 10x. 10 over 5 simplifies to a 2, so this becomes a 2x. That equals 7 over 10 times 10x. The 10s cancel, and we have a 7x there. So 10 plus 2x equals 7x. Again, a linear equation is what we end up with. To solve this, we are going to subtract 2x from both sides. That gives us 10 is equal to 5x. And then if we divide both sides by 5, we get x equals 2. All right, and then we want to check this. Sorry, just wanted to make sure we have enough space there. All right, so if we check, that would be 1 over 2 plus 1 over 5 equals 7 over 10. All right, so to add 1/2 and 1/5, we need to have a common denominator, which is 10. So we can write 1/2 as 5 over 10 and 1/5 as 2 over 10. And then we see that, yes, that very clearly equals 7 over 10. So this does indeed check out. And last one, ooh, look at this fun. We have 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x squared minus 4, which, remember, x squared minus 4 is just x plus 2 times x minus 2. All right, so our LCD in this case is going to be the x squared minus 4. I'm going to write it in factored form, though. It's going to be x plus 2 times x minus 2. This contains all of the denominators, or all of the factors in the denominators that we see there. All right, so we're going to need a little bit more space. But if we multiply each of these terms by the LCD, all right, if we multiply everything by x minus 2 times x plus 2, something cancels. So in the first expression, the x plus 2's cancel. In the second expression, the x minus 2's cancel. And on the other side of the equal sign, both terms in the denominator cancel. So very carefully look at what you're left with, because you're going to have to do a little multiplying here. From the first expression, we're left with 2 times x minus 2. And then plus, from the second expression, 4 times x plus 2. And then that's going to equal x minus 1. So again, if you multiply by the LCD, all of the denominators go away, left with a linear equation here. This would be 2x minus 4 plus 4x plus 8 equals x minus 1. So 6x plus 4 equals x minus 1. If we move all of the x's to one side, we can subtract x from both sides, and that'll give us 5x plus 4 equals x minus 1 equals negative 1. Then subtract the 4. 5x is equal to negative 5. And finally, dividing by 5, x would be equal to negative 1. And we do need to check this. All right, just want to make it a little smaller so we can see the original equation. So our original equation was 2 over x plus 2. So that would be 2 over, let me give myself my space, 2 over negative 1 plus 2 plus 4 over negative 1 minus 2 equals negative 1 minus 1 over negative 1 squared minus 4. Okay, let's simplify both sides and see if we get the same thing. 2 over negative 1 plus 2 is 2 over 1. And then that's plus 4 over negative 3 equals negative 2 over 1 minus 4, negative 3. All right, so on our right-hand side, we're going to leave that as the negative 2 over negative 3. Well, positive 2 over 3 is what it would be. On the right-hand side, 2 over 1 plus 4 over negative 3. We can write that as negative 6 over negative 3 plus 4 over negative 3 equals negative 2 over negative 3. Then negative 6 plus 4 would be negative 2. So yeah, both sides simplify to 2/3, or negative 2 over negative 3. So this checks out, and our answer that we found was correct. So for our first set of practice problems, we have 3 problems here. The first one, 1 over x plus 2 over 5 equals 1/2. The second one, 5 over 3x minus 2 equals 7 over 4x. And the third one, 8 over x minus 10 minus 7 over x plus 10 equals 5 over x squared minus 10. So let's solve part A. We have 1 over x plus 2 over 5 equals 1/2. We look at those denominators, x, 5, and 2. We multiply them all together. We get 10x. That's our LCD. And then we want to take our equation, 2 over 5 and 1/2, and now we're multiplying everything by 10x. Okay, then the x's cancel, that part was right. We have 10. For the next expression, 10 divided by 5 is 2, so we get 2 times 2x, or 4x. And then for the last one, 1/2 times 10 would be 5, so we'd have a 5x. So 10 plus 4x equals 5x. If we subtract 4x from both sides, that gives us 10 is equal to x. Boom, we have our solution. On to B, we have 5 over 3x minus 2 equals 7 over 4x. We multiply each expression by the opposite denominator, or by the common denominator. That would be 3x minus 2 times 4x. Then each denominator cancels out. And we're left with, I'm going to rewrite it so it's a little bit easier to see. We'll be left with 4x times 5 equals 7 times 3x plus 2, or 3x minus 2. Same thing we would get if we cross multiply. That's 25x equals 21x minus 14. Sorry, I'm trying to figure out where this extra thing came from. All right, I don't know what that is. Do I believe me? 20x, 21x minus 14. Yep, if we subtract 21x from both sides, we get 4x equals negative 14, and divide by 4. X is equal to negative 14 over 4, which is negative 7 over 2. And last one, 8 over x minus 10 minus 7 over x plus 10 equals 5 over x squared minus 100. I wrote there that the x squared minus 100 factors to x plus 1 times x minus 1. And then when we write it that way, we can see that the LCD is, right at the top here, x plus 1 times x minus 1. So if we multiply everything by x plus 1 times x minus 1, let's see, x plus 1 times x minus 1 times x plus 1 times x minus 1. Wait, tens. Why am I writing ones when these should be 10? And nobody called me out on it. Sorry, y'all. The LCD is x plus 10 times x minus 10. Then this will actually make our denominators cancel out. All right, on the right-hand side, the denominator x squared minus 100 is x plus 10 times x minus 10. So that'll cancel out. For the middle term, the x plus 10s cancel. For the first term, the x minus 10s cancel. So what are we left with? 8 times x plus 10 minus 7 times x minus 10 equals 5. That's a linear equation we can solve. 8x plus 80 minus 7x plus 70 equals 5. Yeah, and then that gives us x plus 150 equals 5. Yep, I believe me. All right, then finally, if we subtract 150 from both sides, we'll get x is equal to negative 145 as our solution. I believe. All right. I'm double checking, make sure there are no typos. There are no typos. That's our final answer. Problem A here. We have 1 plus 9 over x equals negative 20 over x squared. The LCD here would be x squared because our denominators are x and x squared. So if we multiply each of these terms by x squared, what do we get? This would become x squared plus 9 times x, because one of the answers, x's cancel out, equals negative 20. Because the x squareds cancel out at the last term. All right, so when we simplify here, we end up with a quadratic equation, x squared plus 9x equals negative 20. If we add 20 to both sides, because remember to solve quadratic equations, You need to have all of your terms on one side, and then you want to try to factor. This would be x squared plus 9x plus 20 equals 0. And that factors very nicely, actually. It factors to x plus 4 times x plus 5 equals 0. So if we set each factor equal to 0, we get x equals -4 and x equals -5 as our solutions. And if you go back and plug both of these in, they will. All right. On to problem B. In problem B, we have x minus 10 over x squared minus 5x plus 4 equals 3 over x minus 1 minus 6 over x minus 4. First thing we need to do is factor the denominators completely so we can properly find our LCD. X squared minus 5x plus 4 factors to x minus 4 times x minus 1. This one's set up very nicely for us, okay? Because x minus 4 and x minus 1 are also the other denominators. So our LCD here would be x minus 4 times x minus 1. All right, then let's multiply. X minus 10 over x squared, sorry, I'll just write it in factor form. X minus 4 times x minus 1 equals 3 over x minus 4, 3 over x minus 1, minus 6 over x minus 4. Okay, from here, we multiply everything by the LCD. And then we know all of the denominators cancel. And we are left with, okay, from this first expression on the left-hand side, we're left with the x minus 10 in the numerator. And that's it. Sorry, I forgot to cancel one thing. The x minus 1s also cancel out. So we're left with x minus 10 that equals 3 times x minus 4 minus 6 times x minus 1. This one isn't even that bad. It's not even quadratic. Did I miss something? I don't think I missed anything. This one's just like the last ones. So we get x minus 10 equals 3x minus 12 minus 6x plus 6. So x minus 10 equals negative 3x minus 6. We add 3x to both sides. That gives us 4x minus 10 equals negative 6. And if we add 10 to both sides, that gives us 4x equals 4. And finally, dividing both sides by 4 gives us x equals 1. All right, we are almost done with this section, actually. As you see, the key here is just multiplying by the LCD. Example 3 shows how we can solve a problem or a formula that contains a rational expression. So like here we have 1 over a plus b, 1 over b equals c, and we're asked to solve that for a. You use the same technique, multiply everything by the LCD. In this case, it would be a times b. Then get all of the terms with an a on one side, factor out the a and divide. All right, part A. C over r equals 2 pi, and we want to solve this for r, okay? We can multiply both sides of the equation by r because r is the LCD. And that'll give us c is equal to 2 times pi times r. And then our last step, we want to solve for r, so we want to get r by itself. We can then divide both sides by 2 pi. So we have c over 2 pi is equal to r. And that's it. We can stop here. All right, part B is interesting because you have to be careful with your subscripts, R1, R2, and R. And we're solving for R. So 1 over R1 plus 1 over R2 equals 1 over R. And we want to solve for this R. Right, in this case, all of these are different numbers, R1, R2, and R. So our LCD is R1 times R2 times R. All right, if we multiply each of these terms by R1 times R2 times R, of course, the denominators cancel out. The R1s cancel from the first one, the R2s cancel from the second one, and the R's cancel from the last one. So we'll be left with R times R2 plus R times R1 equals R1 times R2. All right, our goal here is to solve for the R. So we would want all of the terms with just R on one side, all of the other terms on the other side of the equation. Luckily for us, all of the terms with R are already on the left side of the equation. So we can just factor out this R. This would be R times R2 plus R1 equals R1 times R2. And finally, if we divide, we get R1, R2 divided by R2 plus R1 as our answer. All right, last type of problem we're gonna look at is solving proportions. These are my favorites because they're the easiest ones. All right, if we have a proportion is two rational expressions being equal to each other. So two fractions being set equal to each other. So if we have a proportion or two fractions being equal to each other, we can solve these by cross multiplying. So a proportion is an equation of the form A over B equals C over D, where A and B are not equal, C and D, where B and D are not equal to 0, and A times D is equal to B times C. So the cross products are equal. If you have fraction equals fraction, you can cross multiply to solve. So a few of the problems that we had here today could have been solved using this technique as well. All right, first one, let's just do it together. We have x over x plus 14 equals 5 over 7. We cross multiply. That tells us that x times 7 equals 5 times x plus 14. Cross multiply, we end up with a linear equation. That's 7x equals 5x plus, what's 14 times 5? 70. Yeah, all right, and then if we subtract the 5x from both sides, we'll have 2x is equal to 70. And then if we divide both sides by 2, x is equal to 35. So you cross multiply and then boom, no more denominators, you get a linear equation. Before we solved a problem like this by multiplying both sides by the LCD, and then we still end up with the same step. So it's just a quicker way to get to this step. All right, last two problems. We're gonna solve both of these proportions by cross multiplying. All right, so in the first one, x times 7 is 7x, and that's going to be equal to 4 times x plus 12. That gives us 7x equals 4x plus 48. And then move all of the terms with x's to one side. So if we subtract 4x from both sides, 7x minus 4x gives us 3x is 48. And then dividing both sides by 3 gives us x equals 16. All right, we haven't checked the last couple of problems, but we can check our answer here. Is 16 over 16 plus 12 equal to 4 over 7? That's what we're trying to figure out. 16 over 16 plus 12 is 16 over 28. And yes, 16 and 28 are both divisible by 4. 16 divided by 4 is 4. 28 divided by 4 is 7. So these do simplify to the same thing, or both sides of the equation simplify to the same thing. All right. Then last one, 90 or x plus 90 over 25 equals x plus 30 over 15. When we cross multiply here, we get 15 times x plus 90 equals 25 times x plus 30. Okay, when we distribute, we have 15x plus, what's 15 times 90? 15 times 90, 1,350 equals 25x plus 25 times 30, which is 750. Then we want all of the terms with x on one side, all the other terms on the other side. You can either subtract 15x from both sides or subtract the 25x, is up to you. I'm gonna subtract the 15x. That gives us 1350 is equal to 10x plus 750. Then if we subtract 750 from both sides, 750 would be 600. Okay, so we get 600 is equal to 10x, and then divide both sides by 10, and we get x equals 60. We can check this one too. Let's finish out the right way by checking all of our answers. We check here, a little side work. We'll have 60 plus 90 over 25 equals 60 plus 30 over 15. All right, 60 plus 90 is 150. And 150 divided by 25 is 6. 60 plus 30 is 90. And 90 divided by 15 is 6. So that checks out. Both sides equal 6. All right, so our two techniques that we have learned for solving rational equations. One is, if you just have something simple, well, on the simpler side, one fraction equals one fraction, I would recommend using this method. Cross multiply to solve the equations. Or if you have something that, has some terms being added or subtracted, like these two, both of these have terms being added and subtracted on one side of the equation. So here I would use the LCD method.